Hello everyone, welcome back to my channel. Hi, I'm Semantics. Today we have a very interesting question: x plus y equal to 6 and a product x times y equal to 36, and we need to find our x and y. How can you do this? You can also write your solution down into the comment section. In this video I'm going to show you two quick methods how can you solve this question. The first one is like a basic, a classic one. Everyone learned this stuff in school, so right now let's solve this question in terms of like this school method. So first of all, let's rewrite this x plus y equal to 6. Let's start it. So we have x plus y equal to 6, and from here let's express our y. Everyone know how we're gonna do this. We're gonna subtract x from both sides. As a result, we have that our y is equal to 6 minus x. Right, so this is our looks like a substitution. We're gonna plug in this expression in our second equation. In second equation we have a product x times y, so we're gonna start with our x. So we have x times this y equal to 6 minus x equal to 36, and it looks like right here we will have like a quadratic equation, but let's see what will happen. First of all, let's multiply our x by these parentheses. So as a result we have 6x minus x squared equal to 36. And right now, basic things, we're gonna change position. First of all, let's write this minus x squared on the first position, because we prefer our like a classic order: second power, first power, and the constant. So as a result we have minus x squared plus 6x and minus 36 equal to 0. Right now, the final tricky move, we're gonna divide both sides or multiply both sides, doesn't matter. Let's, for example, like multiply both sides by minus 1. We will cancel right here our negative sign. Okay, so as a result, our final quadratic equation looks like that. We have x squared minus 6x and plus 36 equal to 0. So right now let's solve this classic quadratic equation for like all known formula. Maybe a lot of students watch my video, so I'm going to show you how can I solve this step by step. For example, if you're struggling with about a quadratic equation, so right here, first of all, discriminant, quick formula, b squared minus 4ac, and we're going to cancel each of these coefficients. Coefficients looks like that. Right here, a equal to 1, b equal to minus 6, b equal to minus 6, and c equal to 36. So basic classic coefficients. So as a result, we have b squared, we have minus 6 squared minus 4 times 1 and times 36. So right now let's simplify this a little bit. Our discriminant equal to, we have 36 minus 4 times 36 equal to 144. And as a result, a lot of students are confused because we have a negative discriminant. So yeah, it means that we have complex roots. But let's see what will happen when we plug in each of these elements into our x first and second. So we have x first and second equal to, we have minus b plus minus square root of discriminant and all over to a. Classic basic formula. So equal to minus b, we have minus 6 plus minus square root of discriminant, square root of minus 108, and all over all the thing we divide by 2 times 1. Let's simplify this a little bit. As a result, we have right here 6, so we have 6 plus minus this minus 108 we can easily express in another way. We can easily express it as a product. Okay, I write this like that, so minus 108, and right now we're gonna find this factor. So we're gonna divide this 108 by 2 by 3. So let's see what will happen. So 108 right here on the right side, so we have 108, we're gonna divide by 2. As a result, we have 54. We're going to divide this 54 by 2. We're going to have like 27. This 27 can be divided by 3. We have 9. This 9 can be divided by 3. We have 3. Right here we divided by 3, and we have 1. So this 108 we can express as 2 square times 3 square and times 3. Why I split it like that? Because we're gonna talk about square root. So it's easier for us to express this as 2 square, 3 square, and 3. So let's do this right now. So we have 6 plus minus square root of minus 1. First of all, don't forget about it, because we have minus 108 right now, times 2 square times 2 square times 3 square right here, and times we have 3 times 3, and as a result we're going to divide it by by 2. And in the new line, I'm going to split this square root, so we have 6 plus minus square root of minus 1 times square root of 2 square times square root of 3 square and times square root of 3. Alright, we're gonna divide it by 2, and it's a really great moment for us, because right here we're gonna cancel this 2 with this square root sign, this 2 with this square root sign. As a result, right here we have our complex unit, this is our I, and square root of 3. Alright, so we're gonna have like 6 plus minus I in the beginning. The next we have times 2 times 3 and times square root of 3 and all over 2. And to be honest, we can easily cancel this numerator by 2, because we have, looks like we can divide our numerator by parts. Like we can divide this 6 by 2 plus minus I times 2 times 3 times square root of 3, and we're going to divide it by 2. As a result, we're going to cancel right here, we have 3, this is our 3, and right here we're going to cancel this by 2. So as a result, our x first and second, so from here our x first and second is equal to, we have 3 plus minus 3 square root of 3 times I. Alright, this is our x first and second. And right now let's find our y first and y second, but don't forget about the substitution in the beginning, because things y is equal to 6 minus x, okay? So as a result, we can consider y first and y second. So from here, our y first is equal to 6 minus x first. Let's go, for example, with the positive sign, doesn't matter. 3 plus 3 square root of 3 times I. We're gonna have like 6 minus 3 square root of 3 times I. As a result, 6 minus 3 is equal to 3. So we have 3 minus 3 square root of 3 times I. And we're gonna have like y second. So y second equal to y second equal to, we have 6 minus, let's go with negative sign, so we have 3 minus 3 square root of 3 times I. As a result, right here we have 6 minus 3 and plus 3 square root of 3 times I. Okay, so we have 3 right here plus 3 square root of 3 times I, and we can easily write our pairs, because we find our y first, y second, x first and x second, so we can easily write our pairs and we will check our answer. Okay, so it looks like this is our answer, but let's write it first of all, because the next thing we're gonna check it. Let's see what will happen when we check it. Okay, so x and y equal to the first pair, x first, x second, so right here we take the positive one, so 3 plus 3 square root of 3 times I, and y first with the negative sign, y first right here, 3 minus 3 square root of 3 times I. Alright, and the second pair, we're gonna have like 3 minus 3 square root of 3 times I, and the second thing, 3 plus 3 square root of 3 times I. Okay, this is our first method. I'm going to check it real quick. Let's see what will happen when we check it, and then I'm going to show you the second quick method, like the faster than this one, because this is like a basic school method, how we prefer solve this question, this type of question at school. So first of all, let's check it. In the beginning, what do we have? In the beginning, this is our question, so we have x plus y equal to 6 and xy equal to 36. This is our question from the beginning, and we can easily check this one or this one, because this is absolutely the same thing when we check this expression, these pairs of solutions, or this one, because we have addition and doesn't matter 2 plus 3 3 plus 2, we have absolutely the same thing, so it doesn't matter what we're gonna divide for, like this first element to the second or the second to the first, we have absolutely the same thing. And to be honest, the same thing with the product, because 2 times 3 equal to 3 times 2, so we're gonna check, for example, let's check this one. For example, let's start with addition. So x plus y equal to 6. So let's add this one to this one. So we have 3 plus 3 square root of 3i plus 3 minus 3 square root of 3i. All right, so we're going to cancel 3 square root of 3i and minus 3 square root of 3i. So we have 3, we have 6. So addition works absolutely correct. And right now let's check our product. Let's see what will happen when we multiply our x times y. Okay, so we have 3 plus 3 square root of 3i and times 3 minus 3 square root of 3i. A lot of students are confused about it. They multiply parentheses by parentheses, but this is our basic school formula, because when we remember our a square minus b square, this is our a minus b times a plus b. Alright, this is our school identity, and we have absolutely the same thing right here. We have absolutely the same elements. We're gonna talk about difference of squares. So as a result, we will have like 3 square minus b square. B square, this is our 3 square root of 3 times I, and of course square. As a result, we have 9 minus right here when we rate this expression, complicated expression, which like has like a lot of expression like 3 square root of 3i, we're gonna raise 2 to we're gonna raise this 3 by this 2, we're gonna raise this by this 2, so as a result we have 3 square times square root of 3 square and times I square. All right, so as a result we have 9 minus 9 times square root of 3 square equal to 3 and times I square equal to minus 1. So as a result we have 9 plus 9 times 3 equal to 27, which is equal to 36. And yeah, this is a correct roots, correct solution, I guess. But right now I'm going to show you the faster method. So like right here, I think you will see this part. So we have the second method. I hope I'll have enough space right here. So the second method. So in the beginning, what we had? We had this type of expression. So we have quadratic equation x squared minus 6x and plus 36. How can we solve this equation faster than this, like a classic basic method? So just take a look closely. First of all, instead of this 36, let's write 9 plus 27. So we have x squared minus 6x plus 9 and plus 27 is equal to 0. And right now, this is our classic formula. This is our classic formula, x squared minus 6x plus 9. This is our x minus 3 square. So we have x minus 3. We have square plus 27, don't forget about it, plus 27 is equal to 0. All right, the next thing, let's write this 27 on the right side. So x minus 3, we're going to raise this to the second power equal to minus 27. And I don't have enough space, but right here we need to take square root on both sides. And when we take it, we have right here, we can easily cancel this expression. So we have x minus 3. And this square root of minus 27, we can easily split. We can easily write it as minus 1 times 3 times 9. So as a result, we can write it as I times square root of 3 and times 3 when we take this square root sign. And the last thing, we bring this minus 3 on the right side. So we have x equal to, we have 3, but to be honest, we can easily write it as plus minus. And right here, we can easily change position just like for when we're going to get the same root as we did it before, okay? So we're going to have like 3 square root of 3i. We can easily write it because we have a product. So 3 square root of 3 times I. And this is our second faster method to solve this quadratic equation. So this is my explanation to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. I don't have enough space, but this is our answer. So let's write that this is our answer. This is our final answer to this question. So 2 pairs of solutions, complex root, but doesn't matter. We have complex root, but doesn't matter. So thank you everyone for your time. Wish you all the best. See you in the next videos and have a great day.